Hey everyone, welcome back to the channel. We learn about hard links and soft links, how they work behind the scenes, and most importantly, we'll also see the practical demonstrations. So let's get started. What is a link in Linux? So in Linux, a link is a reference or a pointer to a file. Think of a link as something of representing data into a different form. Instead of duplicating data, we are using a method to point the data or naming the same file pointing towards the same data. Now, if you will consider a default Linux system, the slash bin is usually a symlink to slash usr bin on the modern Linux based systems. So we will understand link with the help of an example. So let's consider an example of a library. In a library, you can have multiple copies of a single book. Now consider a shelf like this, like there is a book 1, another shelf with the same copy of book 1. So what is actually happening, we are having the same copy of the same data, but in a different shelf. Same can be done with in a Linux based system. So we'll look what are the different kinds of links we can create in a Linux based system. So in a Linux based system, we have two types of link. One is the hard link and second one is a soft link. So first we'll consider what is a hard link. We'll take a reference from previous example where in a library we have multiple shelves. And shelf had something called as book 1 and this another shelf had a same copy of that book 1. So what happens if book 1 from shelf 2 gets lost or we somehow lost that book? So in that case, we always have book 1 or a copy of the book 1 available at all the times. Same happens in the case of hard link. Hard link is nothing but a pointer to the same data. So the data from this file is pointed by two files, name 1 and name 2. So the contents of the files name 1 and name 2 will be the same, and because they're pointing to the same data. We'll understand hard links better with the help of a real-time example in our systems. So let me quickly move to on my machine. Yeah. So what we'll do is we'll make a directory of our choice for this video. mkdir. Keep the name simple as A1, and I'll move inside this A1 directory. Now you can, if you use ls, you will see that this directory is empty. Now what I need to do is create a file using the cat command. Cat. I'll give the random name to a file h1 because I'm explaining you the example of a hard link. So once I'm inside this cat menu, what I can do, I can write any content like hello, welcome to my channel. Now once I'm done writing this file, I need to press Ctrl D to get out of this menu. So if I now use cat h1, I'm getting the content of the file h1. Now what if I want to access this file h1 file from different locations, or let's say for simpler explanation from this location as well. So what I'll do, I'll use the ln command. Now ln is nothing but the link. So I'll use the ln command to make a link of this h1 file. So first I will use ln, the name of the file which I want to create a link of, that's h1, and next argument will be the name of another file which will have the same content. Now I have used ln h1 h2. Once this is done, and if you use ls, we'll get two files, h1 and h2. Let's see the contents of each one of them one by one. So I'll use cat h1 and again cat h2. Now as you can see, both these files have the same content. But here is the fun part. If I change any one of this file using the cat or any of the text editor, what do you think will happen? Let's check by ourselves. So again what I will do cat, but this time I'll use a double greater than sign. So single greater than sign is used for like deleting the previous content and writing newly to a file. But if you use a double greater than sign, it will append the file. So I'll edit the h1 file using the cat double greater than. But as soon as I press enter, and I need to add some content. So let me add some content right here. Once I am done, again I'll press the Ctrl D. Now we have made changes to the h1 file, so we'll verify using the cat command, cat h1. So as you can see, the line which I added previously got added. But here comes the real magic. We'll use cat h2 to view the contents, and boom, both the files are having the same content. Now you might think, what if I delete any one of the file? Will the content be also deleted from both the files? Let's check it ourselves. So what I will do, I will use rm -recursive enforce h1. Once it is done, you will see that the h1 file got removed and I only have the h2 file. So this time what I'll use, I'll do cat h2, and you can see we have the h2 file intact. So hiding can be used where a single file needs to be accessed from multiple locations and you want to keep a copy always at your place. So this feature of Linux is useful if multiple users are working on a single project and a file needs to be reused at multiple locations. Now here comes the fun part, that there is a concept in Linux called as the inode. So to list the inode, what we can do is ls-i, and I'll use the L to get a proper list. So you can see I get a inode at 3107121. We'll understand about inodes further, but to make things clearer, I will make another link to this h2 file. So again I will use ln h2 and the name of another file h1. It can be now h3 also, it can be h4 also, anything of your choice. As soon as I press enter, I'll get two files, h2 and h4. Now again, if I use the command ls-i, you can clearly see that you have the same inode number for your file. More on inodes later. Now we'll consider what are soft link in Linux based system. Now if you consider hard link, the same data is accessed by two different file names, right? But the case is different in case of the soft links. So what happens in soft links is the data is pointed by a file or file name. The file name can be anything, and the same file name is pointed by another file. So let us understand it better with the help of example, and we'll be seeing what are the different differences between hard link and a soft link. Now I'll clear my screen. Now we basically have two files, h2 and h4. Now what we want to do is create a soft link of a file h2. So for that, again we'll use the ln, but this time we'll use the -s option. Now here -s stands for a soft link. So -s h2, and we are creating a soft link file, so we'll name it s1 for a better understanding. So as soon as I do this and list, now I have three files like ls-il. Now the difference is clear. The hard links which we created earlier have the same inode, like the inode is exactly same, but when we created a soft link, it gets a different inode. So why this happens? Now we have seen earlier that if we deleted any of the hard link file, the data does not get lost. But what if I delete the h2 file? Now we'll see the contents of every file. For that I'll use cat h2, cat h4 and cat s1. So we can say that all the three files are having the same content, but when we created hard link and deleted a file, the data was intact. So we'll just remove the file. We'll remove the file h2 and see what happens. Now we only have the h4 and s1. So here is the difference. You can see before deleting the file, s1 was blue in color, but now it is red in color. So if I use cat command now to list the contents of s1, it says no such file or directory. What exactly happens is s1 has no content of itself. It is pointing to another location. So soft link is similar to a shortcut in a Windows based system. So what is a shortcut in Windows? So whenever you have installed any games on your Windows based system, you made a shortcut on your desktop. So the desktop file, which was a shortcut, was only of 1 KB and pointed to the original file. Same goes the case with the Linux. So soft link is nothing but a shortcut of a Linux based system. Now let us have a look at the features of hard link in Linux. So a hard link file have the same inode as we checked earlier. If any one of the file is deleted, we still have the data, we don't lose the data. Both the files will have the same owner and same permissions. Now hard link is disk space efficient. How we can prove that using a terminal? So let me move to my terminal. Now let me list my directory contents. I have h2, h4. To verify whether h2 and h4 are hard links of each other, let me use the il command. One way to verify whether your files are hard link or not is by checking the inode number. If the inode number is same, definitely both files are hard links of each other. One more way to verify whether a file has hard link or not is by having a look at this number. This number states 2. It means that h2 has 2 hard links of itself. 2 hard links. So what basically is an inode? So inode or the index node is a data structure in a file system that stores metadata about a file. So every file, every directory or special object on a Linux file system has an inode. To make things easier, we'll consider an example. So consider a classroom where we are conducting exams. So classroom will have n number of benches. Let's say 9 for this example. I'll just write the numbers serially for easier understanding. Now consider we are conducting the exam here, and say the students enter the classroom, and after everyone has took their place, we observe that roll number 5 was absent. So what happens in that case? The optimal way was to fit another student in the place of roll number 5. But does that happen in the case of exams? No. We basically keep that space empty and carry out the exams. So same thing happens with the Linux based systems. So we can create files using the touch command. And if you previously know what this touch command is used for, we know that touch command creates a file which are basically of 0 kbs. But by that logic, you can create infinite number of files using this touch command. So how come the system will be able to remember infinite number of files, right? So there should be a limitation or a limiting agent acting in this system. So here we have the concept of inode. So inode for let's consider a physical drive which is of 1 GB. So that 1 GB physical drive, when we start creating files on it, must have some limit, and that limit is decided by the inode. So approximately 1 GB physical drive will have 57,000 inodes. Okay, that means on a space of 1 GB physical drive, we can create 57,000 files or directories, and not more than that. So this is the approximate number. The number varies from system to system, or partition to partition, and their type. Like ext4 will have a little different value, xfs will have a little bit of different value. So let us see how we can view our system's inode usage using terminal commands. To view our system's inode usage, we have a very simple command called as a df-h. So what is the output, basic output of the df-h? So df-h have a location that has a file system location, that /dev sda2. So as I mentioned earlier, sda2 is a partition, and as we can see, its size is 960 MB, out of which 455 MB is used, 506 MB is available. Now we want to view the inode usage of this file system. So simply I'll use df-i. Now the df-i gives us the output, available inodes for a particular file system, how many inodes are used and how many inodes are free. For the /dev/sda2, we have 5,24,000 inodes. That means we can create 5 lakh directories or files in this file system. And we have already created 370 files or directories. So whenever you create a directory or a file in a Linux based system, it assigns a inode. But when it is a hard link, the inode does not get incremented. For multiple files, the inode is same. So you can create multiple hard links, but at the same time not incrementing the inode. But when you create a soft link, the inode is different. So every time you are creating a soft link of a file, you are actually incrementing the inode, which consumes this inode's use space. So I guess that is enough for today's video. We'll be learning more advanced concept in the upcoming videos. Thank you.